In this video, we are going to learn how to address the input, output, timers, counters, bits, integers, and floats. And in this video, I'm gonna talk about particularly of Allen Bradley PLC. Okay, so we will see Allen Bradley PLC's addressings. Okay, so here you can see the input, that is I:0.0/0. Okay, so for a compact PLC with input and outputs are integrated in PLC, hence they have fixed slot 0. Okay, this is slot number. Okay, let me define you all these parameters. This is file name. File name means that is input or output. Okay, this is all this. File name means input, outputs, bits, all these are file name. And after colon, this is known as slot number, that is the input or output cards are attached to which slot of the PLCs. When a PLC is a modular PLC, so they have arranged in a slots, so this gives us a slot number. If we have multiple inputs card in our PLC, so they are arranged in a racks with the slot numbers. So if we want to access this second input card, so we will write here 2 0, and this is second one is word number, so this is our word number. So this is the format of memory in PLC. Okay, so we are using the bit here after slash. This is the bit. Okay, bit number. Okay, so bit number 0 means here. Okay, bit number 0 means here. So this is the 0th slot and 0th word with the input card of 0th slot and 0th number word of 0th bit is selected. Okay, same the output 0. Why we are writing in here 0? Because in a compact PLC, input and output are already mounted in a fixed PLC. Okay, so here we are having same slot numbers, input and outputs, so that's the reason we are writing 0 here. This is not the 0, I'm sorry, this is the O, it is file name, output 0 slots, 0th word, 0th bit. Okay, so for bit means we are having a bit signal, that is lamp or footer, relay, solenoid valve, etc. for just a bit output. Okay, so we could use a full word of a 0 slot, 0th word for a bits or bit 0 1 2. So we have different addressing for that, from 0th bit to 15th, means from 0 to 15 we have 16 slots. Okay, 16 bits, so we would consume all of them. Similarly from, and if we change the bit word number, then we could use another memories 16 bits. Okay, here please, if you want to select different slots, that means we have different modular PLC and we are using different card, so we will write here O:1.0/1 2 or to 15, anything from 0 to 15. Okay, near addressing of bits. Okay, it is simple. This is the file name, means we are calling for bit file name separated by colon, and this is the word number. Okay, word number 0. So because it is the inbuilt bits of the PLC, so it doesn't have any kinds of slots. It is fixed in PLC. PLC gives us some memory for accessing it. So this is the word number and separated by slash bit number. Okay, bit number. So we could use bit for our output latching like that. Okay, and here we have timer. For timer, addressing is starting from T4:0. Okay, or T4:1. Okay, from beyond T4. Okay, and timer timing bit, that is TT bit. I will show the use of TT bit in later on videos. So just understand how we gonna address it. If we are using timer bit 0, timer address is 0, T4:0, then we write T4:0/TT. Okay, if you are using 1, then you write here 1, or 2, or write here 2. Okay, just simple that. What is done bit? Done bit is another part of timer bit, timer instruction. I will show it to you later on. Just mark it up that if you use a timer that is T4:0, then we are gonna use a done bit as T4:0/done. Okay, single bit. For counter instruction, we use counter as C5:0. Okay, or 1 or 2 like this, and done bit as C5:0/done bit, single bit. Okay, and for integers and floats, we have N7:0, F8:0, or N7:1, 2. If you are using N7:0 in our future, in before, that I meant to say, if you are using that N7:integer in our ladder before, then in the same program you cannot use F8:0 because this word number is already taken by the integer. Okay, so you have to use different one. As simple as that. We have another sets of instructions too, but we could see it later on while we are doing solving problems. Okay, thank you guys.